So welcome to this talk. Today I'm talking about Klutch. It's an open source project. In particular, I'm talking about what Klutch can do for Cloud Foundry, obviously. And it's about how to manage data services gracefully in platform environments that, well, let's say, got more complicated since Kubernetes entered the stage. As already said, my name is Julian Fischer. I'm CEO of anynines. And as I said, I'm talking about Klutch. Now, in the past, we did a lot of data service automation, BOSH-based provisioning of dedicated service instances for, the most popular open source databases, and we've been doing that for more than a decade. I was always a bit scared of open source, to be very frankly, but this time we said what we are building now is going to be open source. It's under the Apache 2 license. So everything I'm talking about today is basically out there. The Klutch core itself is open source. There's a bit of a fact sheet that's more to, make a photo because people like to have some sort of, hey, what was this actually about? I'm going to repeat that slide at the end. Long story short is basically it's an open source tool that helps you to do data service orchestration and integration. So we're going to look into closer detail. It works across infrastructures. It is basically a Kubernetes workload, and you can run it wherever Kubernetes runs. It integrates very well with, well, obviously Kubernetes and Cloud Foundry. And also it's meant to help you when you are in an organization where there are a lot of databases. So it's not necessarily if you only have 5 or 10, but if you have thousands, well, then that's maybe something you want to look at. It introduces centralized control, and I will talk about how this is meaningful and necessary. And also, if you're running a Cloud Foundry stack, you know how the operational efficiency of Cloud Foundry is basically unprecedented. We have an ops team that has 10 people that runs roughly 40,000 VMs. I mean, how to make that, and a lot of these VMs are data services. So I want to talk about the tooling, how to get there. Well, then we do BOSH-based automation, but we also do have Kubernetes operators now. We have customers asking for infrastructure-provided data services. Well, and then you have the occasional enterprise data service sitting around somewhere. So there's quite a heterogeneity in the automation backends you're looking at. How to make sense of that in an ever-growing landscape that gets more complex with multiple platform technologies, infrastructures, and data services to integrate. Well, and last but not least, if you're looking at thousands or 10,000s of data service instances you want to manage, well, you want application developers to do that for you. But, giving somebody an operator might not always be the best idea. So I will cover some basic questions about Klutch. And the main motivation, obviously, is if you're running Cloud Foundry, you have seen that, the Kubernetes train has hit the Cloud Foundry ecosystem a while ago. And with all those different ups and downs, it's pretty clear that Cloud Foundry to this day has a stable niche where Kubernetes can't really touch it. And for that reason, the question is, how do you run Cloud Foundry in a graceful manner alongside your Kubernetes clusters that very likely become more numerous over time in your organization? So in our case, a lot of these environments we've been working with, there was a Cloud Foundry, a couple of service broker and data services, or it's automation. In our case, BOSH-based anynines data services. So now, well, just could be any automation, doesn't really matter which one it is. And if Cloud Foundry is all you need, that's fine, we're good. Works, deploy it, you run it. But with Kubernetes, people think about data services in a different way. I mean, you don't have one Kubernetes cluster and throw your entire organization's workloads at it like you would with a Cloud Foundry in, let's say, at least one of your regions. But instead, you're looking at having a lot of Kubernetes clusters. So if you only have one cluster, well then you could throw a bunch of operators in it, you have platform independence, and if the operators do lifecycle management very well, which I doubt most of them do, but still you could get away with this. But if the platform gets bigger and you multiply that pattern, and I mean multiply, then you have a lot of application developers sitting in front of their applications, their Kubernetes clusters, and operators. And managing the lifecycle of an operator is very different from managing the lifecycle of the service instance. And doing both at the same time requires a skill set that's hard to scale across a lot of application developers. So there's consensus across all the people we've talked to. This isn't the way to go for large organizations with a lot of developers. Unless you have the rare opportunity to work with unicorns. I mean, they're hard to find. So how do you actually approach this? And the first and maybe most important perspective beside of the platform operator is the application developer. The situation we are looking at is that, this is talking about the Kubernetes side of things. I'll get into the Cloud Foundry side a bit later. But you have plenty of application clusters. We look at organizations who are looking into the hundreds of Kubernetes clusters. And you have various automation backends. As I said, they could be BOSH-based, they could be operators, they could be infrastructure provided, they could be your enterprise databases, doesn't matter. The first lesson we've drawn from the Cloud Foundry ecosystem is that it's quite a good idea to keep the application separate from the data service. And I think that's a solid assumption that we should carry on. I think also in large Cloud Foundry environments, a good thing to have is the Cloud Controller's central intelligence. It is a central store of metadata. It knows where your service instances are. It knows which applications consume which data service instances. And I think that's a keeper. We also do have the Open Service Broker API, and it introduces abstractions, but also a more rigid way how to implement it. And I would say that's a keeper too, to a certain extent. So we actually, in designing Klutch, we try to make something that allows you to have arbitrary numbers of Kubernetes clusters, where you add a very simple connector, basically introducing custom resource definitions, or so to say native types to the Kubernetes cluster that will resemble and represent service instances, service bindings, backup, and restore for all the data service you want to expose. Now, the Klutch control plane is a central control plane like the cloud controller would be in a Cloud Foundry system. And it basically receives all the declared states from all the application clusters and stores them centrally. So this is where your platform operations team could basically tap into and look like, hey, who's using the most recent Postgres version that lately has been affected by a vulnerability. In the early stages, we made heavy use of cross-plane for writing integrations because, well, that seemed to be the go-to place to reconcile any resource that's outside of Kubernetes, because the Klutch control plane's responsibility is to reconcile the declared state of a service instance with the actual backend. Well, moving forward a couple of years, we now see that cross-plane is nice, but also has its limitations and its scalability issues. So we actually decided that we want to keep it for the integrations that we have, but moving forward, we'll also encourage writing Go operators that are more tailored to the specific needs, and that cross-plane is not necessarily the way to go for all integrations. So the first takeaway from Klutch is we want to have a separation of the application clusters from the data service backends. The developer flow is basically pretty simple. You are sitting in front of an application cluster, write your Postgres instance spec, apply to the Kubernetes cluster, which is then replicated to the Postgres backend in the Klutch control plane. This will then reconcile with the actual backend. So that could be anynines Postgres, this could be Amazon RDS, or whatever your favorite Postgres operator. From this separation, you also invite the challenge on how to connect the application cluster, as a network to the actual automation backend. So we postulate the existence of a network connector interface for which we have created an implementation called the network connector. It's basically using Envoy proxies to, on demand, when creating such a service bind, establishes a network connection from the application cluster to the actual backend. Well, obviously, you can do that for multiple data services across multiple application clusters, so that provides you with a model that resembles the structure of a Cloud Foundry, but where you have Kubernetes clusters instead of segmentation by Kubernetes cluster, so to say. So that's the Kubernetes side of things with Klutch. It provides you with that central control plane that knows across all application clusters where's the desired state of all the service instances, all the service bindings, which, by the way, will create a database user, create a local secret, and your application, reads the secret like you would in a Cloud Foundry. So that replication is done for you transparently between the connector and the control plane. You don't have to take care. They are written in Go. It's a native Kubernetes workload, as I said, and you can do that for any backend. Well, cross-plane or Go controllers for writing those integrations. What does it mean to write an integration? It's basically telling Klutch how to create a service instance, how to create a service binding, how to do backup, how to do restore. So a system with a couple of clusters will then eventually look like this. So in other words, Klutch control plane introduces a cloud controller-like structure in a fleet of Kubernetes clusters. Well, it works across infrastructures. I said that. And the abstractions are basically looking at the Open Service Broker API, asking, well, what was good in the Open Service Broker API, and just take it as a heritage. We don't see it as legacy, but obviously the Open Service Broker API as it is does not translate well into the Kubernetes ecosystem, because otherwise there would have been more adoption by this point. But we don't abandon these abstractions. We try to elevate them. We try to think about, hey, what do we actually have to change in the Open Service Broker API to make them, viable in the Kubernetes ecosystem? Well, we take the service plan, service instance, and service binding concepts because we believe that service plans, for example, are very valuable if you're looking at 2,000 developers who are used to deal with their applications, and they are used to have an operations team take care of operations. You cannot tell them, hey, here's your operator, and you have to now worry about individual settings of your Postgres. It's often not a good idea to do that. So you should be able to customize service instances, but there should be service plans with well-tested t-shirt sizes to choose from. So the service instance concept, the service plan concept, and the service binding would be basically the same as in Cloud Foundry, with the difference that we are a bit more loose on how to define those structures in depth. So we don't expect one Postgres to look exactly like the other if you expose in-depth features of the underlying backends, because that's quite unnatural. Simple service instances should be pretty much the same, but if they get more complicated, they will differ. Well, and then obviously, when we wrote the anynines data services, we learned early on that you need to have a plan for backup and recovery. Because if you don't have that, how would application developers own their instances? You want to avoid those support tickets when, during an application migration, something broke your database and you can't recover. So you need to have something in place. That becomes a first-class citizen in Klutch. We are also having backup plans, which is basically allowing you to declare a backup schedule. And once you told Klutch how to make a backup restore in an upcoming version, the schedule will be for free, so you get backup plans for free, so to say. So we are loosely using these abstractions, but we also allow for more in-depth attributes. Let's say Amazon RDS has different abilities than, for example, a Postgres operator. And that's okay. Just to give you a few examples, this is a spec on how it looks like. It's basically referring to the service plan and to give that thing a name. You can also see that down below it's called AWS Postgres, which is a pod-based backend. And if you want to switch it to a BOSH-based VM provisioning backend, that would be basically the same YAML, but referring to a different backend. So as I said, for simple instances, that they are basically exchangeable. And if you want to do a MongoDB instance, also pretty much the same. I mean, if you have ever seen Cloud Foundry and created a service, that's just the same thing, but in Kubernetes. The same for the service bindings. You refer to a service instance, and that's it. So service instance and service binding are connected through the name. Backup and restore, that's creating a backup. Name the backup, refer to the service instance, and there you go. Restoring, you refer to the backup, and that will be taken care of for you. You can also think of, like, when you have a backup, then making something like a cron job that repeatedly creates a backup is also a low-hanging fruit. So backup plans is something that becomes a low-hanging fruit here. So there's a small demo on how this works. We are showing here that there's an empty cluster that has the Kubernetes, the Klutch client installed. You create a service instance by creating a spec that looks pretty much what you've just seen earlier here, with a few custom parameters, creating a small single instance with a single VM, or a single pod in this case, it's AWS Postgres. And then you kubectl apply that service binding. Well, service instance. Service binding is upcoming. So after creating the service instance, obviously you want to check that something has been created, and that's the case. So you can create a service binding, which will create your Postgres user and a local secret, and all you have to do is, look at the secret, read the data from your app, and connect to your app as you would with the Cloud Foundry environment too. On your local cluster, these are custom resources. You can just enumerate them. On the Klutch control plane, you have all these objects as well. So you can have a global monitoring on the Klutch control plane, looking for service instances across clusters, where as an application developer, you look at your resources. So here you go. That's basically the idea of it. Now, the interesting part for you is, what does it do for Cloud Foundry? Now, if you have something that solves a data service challenge across a fleet of Kubernetes clusters, wouldn't it be nice that once you've written an integration for Klutch, you can also use it in a Cloud Foundry? And that's basically what the Cloud Foundry, the Klutch Service Broker does, that we've created. It means that for any new data service you integrate, you write a Klutch integration, and you have a Cloud Foundry integration more or less for free. There's a bit of mapping code to be written at the moment, and we're still working on some of the reflection, like where do you obtain service plans, as this is not included in the Klutch server by now. But the situation would be then like this. You have a platform environment. In one region, you have a lot of Kubernetes clusters, and you have a Cloud Foundry with the Klutch Service Broker. Well, the Klutch Service Broker becomes, so to say, a front end for the Klutch control plane, and the Klutch control plane takes care of the heavy lifting, which means you don't have to write integrations for Kubernetes and for Cloud Foundry. You write them for Klutch, and you get the Cloud Foundry side for free. So it's pretty much looking at a regular user flow in Cloud Foundry here. On the top, you can see what you do in Cloud Foundry, and at the bottom, you can see what happens in the Klutch control plane. So the CF service, the marketplace, lists all the service integrations that you have, and down below, you can see, well, there's no Postgres instance so far. So creating a service instance is also pretty straightforward. It's empty. No Postgres instance, no logme instance. Could be any other backend, as I said. So the CF Marketplace, you pick your data service you want to create, and then, well, go for it. So the Cloud Foundry Service Broker then talks to the Klutch control plane, and the Klutch control plane talks to the backend, and you can see an instance showing up in the Klutch control plane. And you can do this, obviously, for other data services as well. And it will be the same thing. All right, so another service instance pops up. Well, service binding and service instance service, after you've created the service instance, creating a service binding is pretty much the same thing. You use the Cloud Foundry API to do that. And in the Klutch control plane, the objects show up. It will be reconciled with the automation backend, and there you go. So, question is, where does this lead? First of all, you have multiple application clusters. You have Cloud Foundry. You can create service instances. And I think with a bit more features added to Klutch, you can also have service instances shared between Cloud Foundry and Kubernetes instances. And it also is imaginable to have multiple Cloud Foundries and make Klutch the central cortex, so to say, to have service instances spread across multiple Cloud Foundries as well. So we think about having multi-tenancy capabilities increased and even multi-region awareness in Klutch, which makes Klutch a very interesting tool to orchestrate data services in those more complex Cloud Foundry and Kubernetes environments. And also, as I said, you write an integration for Klutch once. You get the usage in Kubernetes for free, and the Klutch Service Broker here is generic, which means that as long as you stick to those standards, you basically get that integration for free. So here you can see that the service key has been created. There are your credentials. You can connect to the data service instance from a Cloud Foundry that has been created through Klutch. Well, I think from time-wise, you can pretty much imagine how it is to update a service and update and delete a service instance as well. It's basically showing the same procedure. So trying to sum up, we've been looking at Cloud Foundry environments, and we see in all our organizations with our clients that Kubernetes has a coexistence with Cloud Foundry. We can see that there's a dynamic between the two, and we also see that a lot of heterogeneity is coming up in large Kubernetes environments, eating manpower and costing a lot of money. And I think data services is a major challenge, and we try to address that with Klutch. So Klutch enables data service management across Cloud Foundry and Kubernetes platforms and across infrastructure, trying to give them the same on-demand developer self-service as you would have in a Cloud Foundry, across a range of data service backends that are yet to be determined. So I'm not standing in front of you to advocate our data services. If you want to buy them, I'll go for it. But it's about solving that problem in the ecosystem. And, well, if you want to create and expose Kubernetes operators in Cloud Foundry, that's the way to go as well, because that is basically, you get that once, that integration, you do it once, and you get the rest for free. So where do we stand? First of all, the Klutch framework is fully functional. We have multi-tenancy on the list. We have the network connector, at least the first one, implemented based on Envoy proxy, because that one is infrastructure independent, connecting your application clusters to the service instances. But we believe in large AWS environments, you would look into VPC Lattice, for example, so there will be more implementations in the future. The Klutch Service Broker in the first version is available. There are some features missing, for example, how to obtain automatically the service plans. So there's a feature in Klutch missing, so to enhance that feature in the service broker. But it works, and the writing integration for the Klutch Service Broker, once you have an integration in Klutch, is right now a bit of mapping work, but not too much. Backend integrations are growing as well, so we have a couple of them right there, including AWS is in the making. And as I said, this is the overall fact sheet. Now, there's the bit of call to action here for you. We've been building that thing alone for the last 3 years, and it's eating us alive. So it's a quite costly thing to do. There's more than half a dozen people working on this for quite a while. So if you're interested, please get in touch with Klutch. We are looking for people trying to use this and help us building it. So we are looking to both sponsorings, people joining us as contributors, because we believe this is a challenge in the overall ecosystem, helping to keep Cloud Foundry relevant, and also to keep the costs of running data service in Cloud Foundry and manage that to a sustainable level, and also make the Kubernetes promises come true, because I see a problem there too. So if you like it, go by and visit it on GitHub. And we do give demos. I don't think the Klutch team is there. We have a lot of people here. Just find us and talk to us about it. And if you want to have that thing on your infrastructure, we'll help you to do that. We also get a free POC. We'll figure out what's missing, if there's a gap in what we have, and help build it for you. There's also a self-service, which means you can download this on your laptop and try it out yourself. So hopefully you enjoyed that. Otherwise, there are questions. Feel free to ask now or find me later somewhere at the conference. Thank you very much for your attention.